All right, physics students. So what you missed on Friday, if you were gone, is we calculated the potential and kinetic energy from our M&M crash lab yesterday. So potential energy is equal to mass times gravity times the height. Okay, so what you need to do in your journals or on a piece of paper is you need to create this table and you need to calculate the potential energy for all of these variables, because those are the ones we did yesterday. Once you've done that, you're going to choose two more. So I want you to put this example in your notes. It counts as one of them. And then you're going to do an additional two. So here I show you what kinetic energy is. So it's 1/2 the mass times velocity squared. The tricky part is finding the velocity from your data. So this shows you the equation and the values all plugged in, but right here is where we worked to figure out what the velocity was. So you can calculate the velocity for each drop. You don't have to for each drop, just 3 drops. So this is one of them, and then you have to do 2 more. So you have to find the time first, and then once you have the time of the fall, then you can calculate the velocity. Make sure that you use the equation for velocity of gravity times time, not distance divided by time. Okay, that's important. Once you calculate the velocity, you can see that your value here, 3.43, should be exactly equal to what your value is there. So your potential energy and your kinetic energy, they should equal because of the conservation of energy theorem that we're going to learn about. So you're gonna find all the potential energies, because that's just a 3-way multiplication, so it's not too hard. And then you have to do an additional 2. You can choose whatever 2 you want of kinetic energy, like I did here. And remember, for each of those 2, you will have to find the time and the velocity so that you can finish up this equation. All right, thanks.